Hydraulic design of sewers. 1. Quantity is wastewater gravity sewer design. Required pumping activity to press sewers. Hydrogen sulfide in sewers, manholes, building connections, cleanouts, pump stations, and equipment. Alright, quantity of wastewater. For any of the segments proposed sewer with the design, wastewater must be determined. Sanitary or domestic waste based on the population served with the given segment with extraneous infiltration inflow with a contribution and industrial flows must be added to produce design flow. Where existing flow records or data show required flow capacity are not available, the method of the criteria discussed below, you've developed the design flow. Tributary area. The area contributing the wastewater with the particular with the sewer with the segment, the quantity of the wastewater with the collected with a particular segment, and with the dependent upon the type of the personnel with the industrial activities which are regularly found for the area. When no information is available, the existing areas to be served of a survey will require to determine the number of the classification of the person for the type of the industry. Sanitary or domestic waste. Contribution for the population. Domestic wastewater's quantity with the normally will be computed with the contributing population basis. Population to be used with the design dependent on the type of the air with the sewer server. If the area is strictly residential, the design population is based on full occupancy of all housing served in the area. They serve with the entirely industrial design population, the greatest number employed within any area at a time, even though some of the one person also may be included with the design sewer residential area for the sewers, both residential and industrial over the design population includes residents, non-residents, but in the design of the sewer, obvious no person should be counted more than once. Allowance will be made for future population change based on facility personnel requirements, master plan projections. Alright, average daily flow. The average daily flow will be computed by multiplying resident, non-resident contribution populations by an appropriate per capita allowance, adding to flow with the average data flow representing the total wastewater generated over a 24-hour period. However, it's not realistic indicator of the rate of flow waste for the generated over short periods of 8 to 10 to 12 hours, etc. Thus, the average daily flow will be used to design sewers to serve the entire insulation large section of the insulation where a major portion of wastewater is generated by residents over a 24-hour period. Allowances do not include industrial and process waste. These values respect the domestic water quantity of the resident personnel average over the entire insulation of the 24-hour period. Non-resident personnel or civilian employees working 8-hour shifts may be allowed a 30-gallon capita day. Normally, these quantities are be either designed with a wastewater treatment facility. However, they will be either the size of the intercept of the trunk sewers, pumping sanitation serving a large portion of the insulation. For design sewers serving the smaller area of the surveyable buildings or group of the buildings must be considered. Appropriate wastewater allowance should in the table obtained with the standard textbook will be used. In residential area, each of the housing unit must be assigned for 3.6 residents for the purpose of calculating population. For hospitals, no separate allowance will be made with non-patients and employees working shift. Average hour flow rate. When designing sewers to serve small area with the insulation, several buildings, group of the buildings, owner of the consideration majority of the wastewater of the generated non-resident, other short-term occupants, the average of the hour flow rate will be used. The average hour flow rate will be based on actual period of waste generation. For example, 1,000 non-residents at 1,500 liters in 8 hours for an average hourly rate of 14,375 liters an hour, or 247 hours. 3,450 liters a day. Note the average daily flow should be still 115,000 liters a day in 24 hours, but the sewer must be designed hydraulically to carry 115,000 liters in 8 hours, not 24 hours. Peak diurnal flow rate. Normal daily range rate of flow with the diurnal pattern approximately 40% of the 250% of the average daily flow. Of the peak daily diurnal flow rate is an important factor sewer design, especially with minimum velocities are provided with a daily base. The peak diurnal flow rate will be taken one half of the extreme peak flow rate. For your extreme peak flow rate, extreme peak rates of flow occur occasionally must be considered. The several sewers will be designed adequate capacity to handle the extreme peak flow rates. Ratios extreme flow rates to average flow rates will be calculated using the following formula. Ratio extreme flow rates to average flow is equal to constant at 47.71 liters a day or 28.10 liters an hour, times average daily flow, average hourly flow rate in liters per day, gallons per day, or liters per hour, gallons per hour, and that's to the exponent of 0.167. Alright, when designing sewers to serve an entire installation in large areas, installation where the major portion of wastewater generated residents over a 24-hour period with the average daily flow will be used. The formula extreme peak flow rate will be computed in multiplying average daily rate flow with a ratio of R. However, the sewers serving a small area within installation, several buildings and group of buildings are being considered, with the majority of the wastewater generated by non-residents or other short-term occupants. Average hourly flow rate will be used, and the formula extreme peak flow rate will be computed by multiplying average hourly flow rate by the ratio R, which once again with the ratio extreme flow rate over the average flow. Alright, infiltration and inflow. Extraneous flow of the groundwater, infiltration of the sewer systems with the defective pipes and joints, fittings, and manhole walls. Sources of the inflow include connection with the roof ladders, yard drains, storm sewers, cooling water discharge foundation, fountain drains, in addition with the submerged manhole covers. In computing wastewater for new sewers, design allowance of groundwater infiltration of 45 to 95 liters per day, millimeter diameter per kilometer of pipe at 500 to 1,000 gallons per day, inch of the diameter per mile of pipe, and will be added to the peak rate flow. Where infiltration must be calculated in an existing collection system, attempts must be made to obtain flow records from treatment facilities, pumping station, which provide information magnitude of the L to L quantities, the absence of such flow rate, such flow data, depending on the scope of the project necessary for the measure of the flow of the existing system. Where it's not possible or feasible, allowances of 23,500 to 235,000 liters per day or kilometer over kilometer of the pipe must be, depending on the site of the age of the sewers, material of the construction, soil, groundwater conditions. Installation personnel will usually have some knowledge of these materials. These matters should be aware of major problems. The ratio, known as the excessive, should be determined prior to design corrective measures for the planning of the existing system. U.S. Environmental Protection Agency evaluation rehabilitation programs will be implemented. For industrial waste flows, industrial waste quantities of the plant, technical laboratories, laundries, vehicle maintenance shops, wash racks, planning shops, and such industries cannot be computed totally on the population fixture unit basis. Flows of such plants, depending on the type of extent of the activities, industrial waste sewers and sanitary sewers will be designed for the peak industrial flow as determined a particular industrial process activity involved. Alright, 1.5, fixture unit flow. Site of the building connection is also will indicate for the large enough the discharge flow computed with the fixture unit basis requires apply to building connections, not on the lateral or other sewers to which they connect. Alright, gravity sewer design. Sewers designed with the discharge of the wastewater flows are required generally with not desirable to design flow with a full flow. Even the peak rates for flow rates of flows above 90 to 95% of the full depth, considerable unstable may result in the sudden loss of carrying capacity with surcharging of the manholes. In addition, large trunk interceptor sewers laid with a flat slope are less subject to wide fluctuation in flow, and a design with a full flow may lack sufficient air space above the liquid to assure proper ventilation. Adequate sewer ventilation is a desired method of preventing accumulation of explosive corrosive odorous gases, reducing the generation of hydrogen sulfide. Therefore, the tank interceptor sewers will be designed to flow with the depths of the not exceed 90% of the full depth. Laterals and main sewers, 80% of the building connection, 70%. However, regardless of the flow of the depth of the maximized to be used as 6 inches for building connections and 8 inches for all other sewers. Building connections that do not carry sanitary waste and transport liquids with little or no solids, such as condensate lines, can be smaller than 6 inches, but no smaller than 4 inches. It's recommended in most situations industrial applications will use the same design criteria sanitary sewers, except pipe material that is resistant to the waste will be specified. The following formula, charts, procedure, criteria will be used for design. Our design formula and charts. The Manning formula will be used for the design of gravity flow sewers. That's V as in velocity in meters per second is equal to 1 over the SI units divided by the coefficient of pipe roughness times hydraulic radius in meters and feet to the exponent of 2.3 times S, slope of the energy line meters pipe feet per foot at the exponent of 1/2. Alright, your roughness coefficient value for the of n will maybe either the full formula range with a 0.01 1300s to 1500s of the lowest value applied with no newly relative to the new pipe in a section greater than 5 feet. Smoother interior surface, smooth blower, even joints, excellent good condition, well constructed. Higher n values are required to for the older pipe with the rougher interior surface open and protruding joints and fair bad condition, properly poorly constructed values up to 1700s are justified with the very old pipes such as brick block sewers. Extreme deterioration of the pipe, very poorly constructed and improper alignment, sagging bellies, cracked and offset joints, broken wall sections, internal corrosion. Some manufacturers' plastic asbestos chemic pipe report in values of 9,000 to 11,000. However, due to the uncertainty, design, construction, place, desire provided marginal safety end values smaller than 13,000 will not normally be permitted. Valuation and with the depth of the flow has been shown experimentally and may be considered designing sewers of flow partially with a solution of the Manning formula to the full pipe flow is shown in Figure 1. And this shows your chart for Manning figures formula. Our velocity. Sewers will be designed to provide a minimum velocity of 6 tenths of the meters per second, 2 feet per second with the average daily flow with the average hourly flow rate minimum velocity of 2.5 to 3.5 feet per second. Peak diurnal flow rate velocity drops below 0.3 meters a second. During periods of flow, organic solids suspended with the wastewater can be expected to sell out in the sewer sufficiently velocity of 2.5 to 3.5 foot per second. Most of the well regularly since once or twice a day minimum. The resuspended flush out solids which may have been deposited during the low flows. Velocity of 2.5 foot per second minimum required to keep the grit and sand suspended. However, the new sewers, which are properly designed, construction should contain only minor quantity of the grit and sand. Minimum velocity is set at 10 feet per second in the event of the grit becomes a problem. Alright, slope. Assuming uniform, the value S of the Manning formula is equivalent to sewer invert a slope of the pipe. The slope of the must be sufficient to provide required minimum velocity depth of the cover of the pipe. Although it is desirable to install a large trunk interceptor sewer with that flat slope with the reduced for the excavation construction costs, result in low velocity emitted to deposit the objectionable solids in the pipe, creating the building up a hydrogen sulfide that must be avoided. Alright, cover. Adequate cover must be provided with the frost protection, generally with a minimum of 2 feet of the earth required to protect the sewer against freezing, frost by penetration. Considerable greater depth lasts over an appreciable length of time. The waste might not contain sufficient heat to prevent gradual cooling, sufficient earth and building up of the ice films inside of the pipe. Under these conditions, greater cover will be required. Sufficient cover must also be provided to protect the pipe against structural damage to superimposed surface loadings. 2.2 Design procedure. After preliminary layout has been made, the tabulation should be prepared and convenient for the setting forth of the following information each of the sewer section. Designation of manholes by numerals and letters, contribution population, resident, non-resident, design flow, average daily peak and extreme peak, length of the sewer, invert elevations, invert slope or gradient, pipe or diameter, roughness coefficient, flow of the depths, design flow, velocity of the design flow, and depth of the cover of the pipe, maximum and minimum. Or your hydraulic profile in most situations where small to medium sized gravity sewers are installed for the long runs, it will be safe to assume the uniform flow through the entire length of the conduit. However, in case of a larger sewer of 24-inch diameter and above, the constructed runs less than 100 feet and with a number of the control section, a non-uniform flow may occur. A plot hydraulic profile is recommended for the processing, planning, pipe of the waste treatment. With the facilities, hydraulic profile is always required. Method used to calculate plot hydraulic profiles include backwater curves, drawdown curves, hydraulic jumps, which will form the present standard hydraulic textbook. Critical flow. Gravity sewers will ordinarily design maintain sufficient of the flow condition for the pipe throughout the normal range of the design. However, there are exemptions. Supercritical flow with the may be required will be justified. Minimized size of 150 to 200 millimeters. Design change. Discharge vary flows most occasionally be placed on slope steeper than critical in order to provide minimum velocity. In addition to the small, medium size sewer required to discharge usually large flow may necessitate supercritical slopes. Final steep slopes may be unavoidable due to the natural topographical ground conditions where supercritical flow will occur. Care must be taken in the design to ensure that the downstream pipe conditions do not induce hydraulic jump or other flow disturbances to the depth of the flow within 10 to 15% of the critical likely to be unstable will avoid where the pipes will flow 15 to 90% full. Critical depths of the various flows pipe diameters can be attained by standard hydraulic textbooks. Our computer programs. Numerous computer programs are available for modeling data management, such as location, diameter, depth, slope, capacity, each sewer compartment, design and analysis of the sewer system, as well as being used to design new systems such as programs consistently assessing impacts of the chain of addition to existing systems, thus helping optimize design. Three-dimensional models may allow the designer to detect interference with the utilities. R3, required pumping capacity, proper selection number and capacity of the pumping units depending on the quantity of the variation of wastewater flow handled, except indicated below. Small stations pumping units will be selected to handle the normal daily range of wastewater flows generated in the surface area of the normal capacity of the pump to provide with a sufficient discharge minimum. Average peakly daily extreme peak flow ration. Pumping capacity will adequate to discharge peak flow rates, load your pump out surface. Utilization will be given as a further consideration which may occur normally with the future development. Population increases are projected for the area of the pumps will be designed initial conditions only. Station will provide adequate room for the expansion of the minimum pumping capacity later date. Expansion of the pumping capacity could be accomplished with the installation of additional pumping units, large pump impellers, drive units, adjustable variable speed drives. However, some situations may warrant provisions of capacity feature increase initially for economic other reasons. Each case will be analyzed individually. Alright, small stations. Pumping stations require that small remote areas generate extreme peak flow rates of less than 700 gallons per minute, whereas possibility of future expansion in unlikely grinder pump installation serving three or more buildings provided with two identical pumping units. Each pumping unit will be constant. The speed type of be capable of discharging extreme peak water flow rate. The station will be designed to alternate with a zero discharge and peak discharge. The arrangement will provide 100% of the standby capacity to allow the necessary maintenance for the repairs. Pneumatic air ejector stations will be provided with a duplex ejectors each size with the extreme peak flow rate. Large stations. Pumping stations serving the large area installation specialty stations with entire wastewater flow or main portions thereof may be pumped. The treatment facility will be designed so far as practical to operate on a continuous basis. Wherever the pumpage must change and increments in flow of the stations varies. The mode of operation normally requires two or more wastewater pumps with constant variable speed. Operating in single multiple pump combinations required at much income flow rates. 4. Depressed sewers. Our velocity flow analysis. Since the depressor with an inverted siphon installed below with a hydraulic grade line with a pipe always will be in the full underwater pressure, even though there may be little or no flow. Thus, design requires special care with circular velocity to preventing clogging due to the sedimentation of solids. Therefore, the velocity may be high practical with a minimum requirement set at 1 meter per second or 3 feet per second. Hydraulic calculations may be based on the Manning formula. Hayes and Williams analysis minimum Manning roughness coefficient of 15 thousandths is recommended due to the impossible accumulation of the grease and other material in the pipe walls. The pipe may be small, available to head pipe permits, except the pipe smaller than 6 inches is not permitted, and so much of the sewer must be sufficient size to discharge extreme peak flows. Better velocity for the normal range of flows that can be often obtained with using several small pipes instead of one large pipe. This requires external entrance box equipped with a diversion gate with a periodic alteration of pipes and served with other overflow weir as so arranged that when the flow exceeds the capacity of one pipe, the excess can overflow to the other pipes. However, the conditions might be such that 2 or 3 pipes in lieu of the one would not be advantaged if necessary. Each will be analyzed individually. 4.2. Cleaning inspection. Depression sewers should be flushed frequently, inspected to make sure the obstruction is removed. Therefore, manhole structures clean out chambers will be required at each end of the sewer to allow the excess routing and pumping. Pipe materials. Since depressed sewers withstand internal pressure for the greater atmospheric, pipe materials required for you to indicate the force of the mains. Alright, hydrogen sulfide in sewers. To the most important problems occurring with the wastewater collection, 1, the corrosion of the sewer, but the prudency, with the 2, the propagation of emission, with the odorous and toxic gases, but these problems can be attributed to the large part of the generation of hydrogen sulfide into their reference for the U.S. Environmental Protection Agency publication process design manual sulfide control of the sanitary sewer systems. For a complete discussion of the top of the sewers will be designed hydraulic in accordance with the EPA guidelines established therein to prevent excessive generation of hydrogen sulfide and general small diameter sewer that designed to maintain velocity greater than 0.6 meters 2 feet per second with sufficient air to wastewater contact normally experience no significant buildup of the hydrogen sulfide. Large sized sewers must be susceptible. Hydrogen sulfide formation rates of generation can be reduced throughout the proper design with a concentration limited to less than 1.0 milligram per liter. Alright, corrosion control. Where to determine the permit exhibit the damaging hydrogen sulfide concentration of the cause of microbiological induced corrosion or corrosion such as new sewer connections to older sewer systems. A historic hydrogen sulfide problem with deterioration through the pipe materials must be selected with the MIC or microbiological induced corrosion and attack from sulfuric acid. Pure plastics of PVC and ABS, fiberglass, verified clay are best suited for the corrosive environment, whereas concrete includes ABS composites, ductile iron, cast iron, solo pipe should be avoided unless the special protective linings and coatings and treatments are provided. Sewer gases. Designing sewer system consideration will give them the possibility of objectionable orders being emitted with the manholes and sewers. New sewers connection to older sewers that have a history of hydrogen sulfide problems will very likely experience similar difficulties. In these cases, sewers and manholes will be located except for the emission of the odor and sewer gases. In particular, hydrogen sulfide do not create a nuisance hazard for the new building occupants. 6. Manholes required. Manholes are required at junction gravity sewers at each of the pipe direction, size, and slope, except within the outer air and after the building connection. Spacing. The distance between manholes may not exceed 400 feet and sewers less than 18 inches in diameter. The sewer of 18 inches in diameter or larger outfall wastewater treatment facility spacing up to 600 feet is allowed, provided with a velocity sufficient to prevent sediment of the solids. Piping connection. The crown and outlet pipe of the manhole will be on line with the below of the ground over the inlet pipe. When the conditions such as produce the unusual turbulence of the manhole, especially with the side of the outlet pipe, it is to be smaller than the inlet pipe because of the available more favorable slope. It is being necessary to provide inverted drop to allow for the entire entry head or increase velocity of the head and bowl of the inverted inlet pipe would be more than 18 inches above the manhole floor. Drop connection will be provided. Frames and covers. Man top elevations will be set to avoid suburgency of covers surface water runoff and ponding where this is not possible. Watertight covers will be installed to prevent stormwater inflow. Bolting locking device will be included on covers to prevent unauthorized entry in areas designated by using agency. Secure of the frames and covers may be sufficient to withstand impact of wheel loads where subject to the vehicle traffic. Covers are nominal 30 inches large. Diameter shall be installed where personal entry may occur. 6.5. Design standards. Where suitable standard drawing specification exists, usable design, manhole structures, usually special design required, following construction practices required. Smooth flow channels will form in the manhole bottom, laying half tile through the manhole, full pipe to the top of the pipe with the breaking out later for the acceptance alternatives. For manholes 12 feet in deep, one vertical wall with a fixed side rail ladder will be provided. Drop connections designed as an integral part of manhole wall and base. Areas subject to high groundwater table. The manholes will be constructed with materials resistant groundwater infiltration. Alright, 6.6. Materials of construction. The primary construction materials used for the manhole construction: 3 cast concrete rings, prefabricated PVC, high density polyethanol fiberglass units cast in place, reinforced non-reinforced concrete and past mass. Most manholes will break, built in brick mason area, and are now frequently source of significant volume of groundwater infiltration. Most recently, attempts to alleviate the problem precast concrete, plastic, fiberglass manholes have been utilized. Certain situation precast units will not be suitable with the cast-in-place reinforced concrete will be required. Cast-in-place construction permits greater flexibility configuration elements by varying reinforcement of the strength of similar sized structures can be adjusted to meet the requirements. General materials used should be compatible with local construction resources. The local labor experience should be cost competitive. Alright, 7. Building connection. Building connection will be planned to eliminate the many bends of the practical and provide convenience in rotting bends greater than 45 degrees, made of one fitting Should be avoided. Combinations with elbow 45 to 45, 30 to 60 degrees should be used with the cleanout, provided general connection to the over sewers will be made directly to the pipe stand fitting rather than through manholes. However, the manholes must be used in connection with more than 30 meters, 100 feet of the building cleanout. Remember, the cleanout inside of the building will not be adequate for the complete rotting. The outside cleanouts will provide insulation. Two-way cleanout at the building connection 5 feet from the footing is recommended. The manholes installed with the cleanouts are not feasible. 8. Cleanouts. Cleanouts must be installed with a sewer design connection, building connection with a provided means of the insert and cleaning rods with the underground pipe. An acceptable cleanout will be consist of an upturned pipe terminating at a slight above final grade with a plug and cap. Preferably, cleanout pipe will be the same in the diameter as the building sewer, never smaller than 6 inches. Alright, pump stations and equipment. Type of the class of construction. Classification pump stations by capacity of the method of the construction normally utilized with the capacity provided in Table 1. Factory assembly mobile pumping station. Commonly referred to the package type station manufactured standard size with a ship of the factory modules. All equipment and components mounted and installed ready for connection. The type of the station suitable for low flows were needed to protect pumps, but the clogging is not minimal. The conventional field erected pump stations are designed for a particular location. Means specific requirements. Field construction stations will be used with the quantity of the flow or variation both exceed the capacity of the available factor for the assembled stations, and where site conditions require use of special design construction method. Table 6.1 shows the classification pump, their class type, and recommended capacity liters per second or gallons per minute. Alright, 9.2 pumps. Centrifugal pumps. Centrifugal pump, the predominant type of the wastewater pump used. The pumps are available in 3 variations: radial flow, mixed flow, axial flow. Centrifugal pumps will not be used with a capacity less than 6 liters per second or 100 gallons per minute. Radial flow pumps. Radial flow centrifugal pump, major type used with the pumping raw waste. Radial flow pump, fluid enters the impeller axially and is discharged with the right angle to the shaft. Type of the radial fluid flow pumps are available with single suction, double suction, single-ended suction pump. Fluids enter the impeller from one side of the shaft as an extent of the suction passage back over the rags and trash. Not clog the pump. Single end of the suction pump will be suitable for the handling untreated wastewater. For double suction pump, filters enter the impeller both sides. However, the shaft extends into the suction passage, thereby limiting its use for the handling only clear water. Radial flow centrifugal pumps are available in discharges of 2 to 20 inches. However, the pumps with a capacity of 3 inch minimum solids will be required. Recommended capacity ranges are 100 to 220,000 gallons per minute. Pumps are available to discharge heads up to 25 to 200 feet, titled dynamical head. Peak design efficiency range 60% of the smaller pumps, 85% of the large pumps. Radial flow pumps are suitable either well or dry well applications. They can be installed horizontal, vertical shafting, or vertical shown pumps requiring considerable list of space. Your mixed flow pumps. Mixed flow centrifugal pumps, intermediate design, medium between radial flow type of the axial flow type of the operating characteristic of both. The mixed flow pump is designed to with wide unobstructed passages is therefore suitable to handling water for clear water. Mixed flow centrifugal pumps are available in 8-inch to 84 through 84-inch discharge side. Recommended capacity ranges between 60 to 55,000 liters or 1,000 to 80,000 gallons per minute. Pumps are available to 3 to 18 meters or 10 to 16 feet of total dynamic head. Peak design efficiency depends on the size of the characteristics of the individual pump, but generally ranges from 80 to 90%. Mixed flow parts. Pumps are used only in the dry well applications in either horizontal vertical shaft configuration. Alright, axial flow pumps. Axial flow centrifugal pumps will not be with the pump rate raw, untreated waste point of the pump. The design primarily with the clear water surfaces for the wet well insulation. Pump is furnished with a vertical shaft with the bottom suction, with the properly mounted near the bottom of the shaft, enclosed in a bowl. Proper total submerged in the clog with large solids range and trash. Therefore, pump will only be used to clear well application. The axial flow centrifugal pumps available in 8 inches to 72 inches. That's short size. Recommended capacity ranges between 500 to 100,000 gallons per minute. Pumps are available to the range of 1 to 40 feet total dynamic head. Alright, pump construction. Centrifugal wastewater pumps will be normally constructed with a cast iron, bronze, stainless steel trim, or either cast iron or bronze impeller. For the operating of the wastewater obtained with a subsequent quantity of the grit impellers made of bronze pounds cast steel, stainless steel will be required. Closed impellers will specify with the wastewater pumps are required as brass solids. Pumping casing of volatile type will be used for pumping raw water, untreated wastewaters, and containing solids. Diffusion turbine type casings may be utilized affluent with a clear water waste treatment facility pump shaft with high grade of forged steel will be protected with renewable bronze stainless steel sleeves where the shaft passes through the stuffing box. Stuffing box will utilize the packing glands or mechanical type seals. Alright, your stuffing box. These stuffing box seal the stuffing box lubricated seals again for the leakage of wastewater into the box with greasable potable water and other clear fluid. Lubricating sealing medium with supply with the stuffing box at a pressure of 5 to 10 psi greater than the pump shut-off head. Grease seals are usually provided with the cartridges with either spring-loaded pressurized connections of pump discharge. These arrangements generally do not sufficient seal the pressure of the stuffing box, however they are acceptable low-head pumps and where wastewater contains a little grit when pumping tread effluently when the pumping raw untreated waste in usual quantities grit and potable water seal system. Seal pump will be required for the potable water line accessible within a reasonable distance. Water seal systems will be capable of 3 gallons per minute per pump minimum. Principal advantage of the water seal over the grease seal is the positive pressure maintained on the stuffing back for the seal of the pump. A small amount of the water flows with the stuffing back from the pump casing. Grit other than abrasive material of the baby in the wastewater, thereby preventing the entry of the stuffing bag, reduce the wear of on the shaft. The packing advantage of less frequent repairs of the shaft leave a leak. Less frequent repacking should be considered with the relationship with costing, providing water line other necessary facilities with water seal. Where freezing and sealed water is likely to occur, protect materials may be taken. This must be used under any conditions. The direct connection between wastewater pumps, potable water system, or any possible backflow of the water waste into the potable water system. Air Force facilities will comply with the Air Force Manual 8521. Alright, screw pump. Screw pump is classified as part of the displacement pump that such maintains the two-disc advantage over centrifugal pumps can pass. Horizontal clogging can override the wide range of flows and relatively good efficiency. With the screw pumps are normally available, the capacity ranging from 10 to 3,150 liters or 150 to 50,000 gallons per minute. Maximum lift of 9 meters or 30 feet. Because of the non-log clog capabilities, wide pump range screw pumps is best suited with lifting raw untreated wastewater into the treatment facility and pumping of the treated effluent. With the treatment plants upgrade of the screw pump may be installed without overcoming the additional head loss. With the new treatment units, though existing discharge facilities can be retained. Screw pumps usually driven in constant speed motor with the gear reduced and inclined with angles of 30 to 38 degrees from the horizontal. Most instances, screw pumps will be installed outdoors only to drive with the units enclosed. Alright, pneumatic injectors. Pneumatic injector station will generally be used only with the situation quantities of the wastewater is too small. More convenient will pump with the future increase of the wastewater flow projected to be a minimal. But pneumatic injector consists of a receiving tank, inlet and outlet, check valves, air supply, liquid level sensor of the wastewater, reach of the present level. The receiver of the air is forced into the ejecting wastewater. When discharge cycle is complete, the air shut off with the wastewater flow of the inlet to the receiver. Generally, the duplex injectors operate on a 1-minute cycle, filling for 30 seconds and discharging for 30 seconds. Thus, each receiver tank will equally volume in 30 seconds for extreme peak flow rate. And pneumatic injector station available capacity ranging at 30 to 200 gallons per minute. Will recommend operating heads up to 60 feet of total dynamic head. A typical injector's installation will include duplex head, duplex unit with 2 compressors, receiver levels, and sensors, etc. Grinder pump. Grinder pump shed solidity normally found with the domestic wastewater include rag, paper, plastic, and slurry may be pumped under low head through the pressure saver as in 1 1/4 inch in which the diameter grinder pumps are submersible installation recommended at 10 to 100 gallons per minute. Pumps are available in discharge heads of 3 to 45 meters or 10 to 150 feet total dynamic head. The peak design efficiency generally very low. Grinding pumps will be used only to handle domestic type waste from one more individual buildings, only remote areas with the gravity sort of centralized pumping facilities are not feasible. Alright, then it goes into the final exam, and that concludes your introduction, JP Galler PE PDH course, Introduction to Hydraulic Design and Sewers. Testing.